So thank you for the invitation. It's really nice to be here. I crammed a lot of information into this talk, so I hope I'm going to get through it on time. So I'm just going to jump right into it. Yeah, and I started off with this question, do we need more forest reserves or strict forest reserves in Europe and Slovenia? So I'll try to answer that today. But let me just start out really generally. So as most of you know, the human population is growing, and we're supposed to hit something like 11 billion by the end of the century, which is a really staggering number. And not surprisingly, the demand for wood basically keeps track with the human population growth, right? So you can see that very clearly here. So in other words, we need to produce a lot more timber over the next century. Same thing in Europe, right? This graph shows timber production in Europe over the last 20 years, and it's predicted that we're going to need to produce a lot more over the next 20 or 30 years because biomass is considered carbon neutral in the European Union. So if we want to reach a carbon neutral society by 2050, we need to produce a lot more timber, okay? And we export a lot of timber too. So that should be very clear to everyone. Globally, we need to produce more wood. The challenge here is that when you produce more timber in a forest, usually there's a trade-off with biodiversity, at least some biodiversity, okay? And so this is one of the greatest challenges to managing any forest. And at the same time, we have to get our forests to adapt to climate change. So doing all this all together is exceptionally difficult. There's basically two ways, kind of really dichotomous ways that society deals with this problem or manages forests. One way is called a land sparing approach, right? That's where you take half of your country's forests and protect it in a strict forest reserve and allow old growth forests to develop. That protects native biodiversity. And then to produce timber, you use fast growing plantations of some kind of tree species, right? The alternative approach is this land sharing approach, is what we do here in Slovenia, where we produce timber and maintain native biodiversity in the same time, in the same place. Most of the world does this first approach, right? Slovenia is probably one of the best examples in the world of this approach, right? Some of the best management in the world. Europe as a whole is something kind of weird. So I don't know if you can see this very well, but the dark green part of these pie charts is how much forest area each European country sets aside in strict forest reserves where there's no management. All right, so most countries don't really set aside much area in strict forest reserves. It's usually 1, 2, 3%. In Slovenia, we have about 1%. Okay, and that's consistent over most of Europe. There are a few exceptions. So we're not doing very well as far as following this new biodiversity strategy. As a result, we manage something like 90% of the landscape. There's parts of the landscape we can't get to. I'm sure if we could, we would. But the result is over a large, continental scale, we don't have these old growth features anymore. So like very large trees, trees are allowed to die naturally in the forest when they reach their natural longevity. So large amounts of dead wood accumulate, high quality dead wood, snags, cavities, all these things that are common in old growth forests that we're lacking on a continental scale. And I realize most of you probably know this already, but that's problematic for a lot of biodiversity. So the biodiversity experts suggest that something like 20 or 25% of all the species that live in our forests require dead wood at some point in their life cycle. And so if we remove that habitat over most of the landscape, then you can imagine what happens to many of these species. So we're talking about many species of lichens, bryophytes, fungi, insects, especially beetles here, saprophytic fungi, many species of beetles. And if you just look at the IUCN data, which is really kind of coarse scale data, this is just showing it for deadwood-dependent beetle species. Many species are threatened. They estimate something like 20% of them. And many species are in decline, their populations. But I think what's kind of scary is we don't really know what's happening with most of these species because it's hard to monitor population trends of fungi and insects and things like that. We can take a closer look at Slovenia because Slovenia is a pretty good case study of this kind of problem, even though we have, I would say, world-class management here. Right? Slovenia has about I don't know if this number is still accurate, let's say around 160 forest reserves. So it's quite a lot of forest reserves, but they're really small, right? So most of them are, say, below 50 hectares. And if we look, we can look at the habitat conditions in these forest reserves compared to the managed forest around them. If we just look at total deadwood volume, for example, in old growth reserves, right, we have about an average of 165 cubic meters of dead wood in our old growth forests. In our managed forests, so Alesh, this should be 21, right? I guess, I think I got this wrong. So we're doing pretty good in Slovenia as far as deadwood. I'd say it's probably one of the best in Europe as far as that average goes. But the difference between the old growth, which is what you would expect without management, and the managed forest is huge, right? So that's like an 80 or 90% loss of habitat for deadwood-dependent species. You can also look at deadwood quality, right? So the proportion of deadwood in the old growth forest is mostly comprised of large logs, right? It's not surprising. And then in managed forests, the deadwood is mostly small branches and things like that, all right? So that also has an effect on biodiversity because many species have evolved to require large pieces that decay differently than small pieces. You can also look at the distribution of large trees, which is an indicator of a habitat tree before it dies. And so in old growth forests, we have quite a high density of them, so trees over 50 centimeters. And in managed forests, there's a much lower density, okay? So it's totally expected, but this has consequences for biodiversity. If you just, so like in any country, Slovenia doesn't really have great data on population estimates of biodiversity. The best data is probably from DOLPS. And so this is showing the distribution of this particular species, the whiteback woodpecker, which is really connected with deadwood. And it's quite rare in Slovenia. There's not that many breeding pairs left. And where they occur, they usually occur in forest reserves. It should, however, because it's a species that likes to live in beach-dominated forests, it should be widespread in Slovenia and it should be abundant, but it's not. So if this species is not doing well, then we might hypothesize that other species that require large amounts of deadwood are also not doing well. Although we can't say that. So that's what I wanted to mention first. We need old growth forests and forest reserves for biodiversity, but we also need them to capture disturbances, all right? So I know a lot of people say, oh, disturbance is bad. It's bad from the perspective of a forest owner, but it's not bad from the perspective of biodiversity, right? And so these kind of events, wind throws, snow breaks, bark beetle outbreaks, these are all natural processes in our old growth forests. And what they do is, the wind throw, actually from this year in the Kurma Valley. Very nice example of a typical kind of windstorm in our conditions. And the reason these disturbances are important are because, I don't want to get into too much detail here, but this is a study from Germany that looked at deadwood-dependent beetles in shady positions in the forest and sunny positions. And you can see that there's a totally different community of beetle species in sunny positions than in shady positions. And often there's more species richness in such areas. And the only time we get a lot of deadwood in sunny positions in the forest is when we have a disturbance, right? Of course, what we typically do in Europe is after disturbance, we salvage log. Makes sense. We want to get the money out of the forest. There's nothing wrong with that. But that's why we need forest reserves to capture disturbance. Now, this is where the news gets even worse. So if you look at the size distribution of forest reserves, strictly protected forest reserves across the whole continent, we recently did a study on this. There's something like 30,000 strictly protected reserves across the whole continent of Europe. Something like 70% of them are less than 50 hectares, okay? You can almost count on the few hands in our audience here how many of these places are larger than 10,000 hectares. So across the whole continent, we're not only not protecting old growth forests, we have the ones that we have are really tiny. And that's not good for capturing disturbance. So this is just an example. These little colored polygons here are damage patches from a windstorm in Slovenia. And you can see this, if we just randomly placed a 50-hectare forest reserve on this landscape, chances are we're not going to capture any of this event, right, let alone all of it. Right? We actually need reserves that are upwards of 5,000 hectares if we really want to capture natural disturbance regimes. I think it's feasible in some areas. It's not feasible everywhere, right? All right, so I want to switch gears now and talk about carbon, because I promised I would talk a little bit about how this relates to climate change. And I don't know, probably some of you have seen carbon budgets like this. So this is the latest global carbon budget, where you can see emissions here, right? That's where we're pumping CO2 out. And then the world's oceans, forests absorb much of that carbon, right? The stuff that doesn't get absorbed remains in the atmosphere. That's this part, about 40% every year. But you can see this, the green part is forest, right? Forests absorb a pretty significant amount every year. But what scientists are really concerned with is that it looks like this curve is leveling out, right? So that could be because there's more mortality in forests around the world. And so one concern is that if we protect more old growth forests, well, they're just going to die off because of climate change. And indeed, if you look at the latest data from managed forests across the continent, you do see increasing rates of mortality, but that's largely because European forests have gotten older, there's been more disturbance, there's been increasing rates of tree harvesting. But the point that I want to make today is that if you look at any data from old growth forests, there's absolutely no evidence that there's been any increasing mortality rates. Slovenia provides a pretty good example of this because we have really good data in Slovenia. I don't know if you can see them here, but we have a small number of old growth forest reserves in Slovenia where we've been tracking individual trees in large plots for about the last 40 years, largely because of Professor Dusan Mlinček helped set up these plots in the 1980s. And we remeasure them every 5 years. And I'm just showing you here data from the beech trees in these forests because it's the most dominant species. So the y-axis is the annual mortality rate, so how many trees die every year. In most forests, you expect a rate of about 1% per year, so one tree out of 100 dying every year. And you can see there's a lot of squiggly lines here. So these higher rates are always from disturbance events like wind throws or something like that. But what I want to show you is that there's no trend, right? And if you run different statistics on this, there's no increase in mortality rates. And that's exactly what we find in all old growth forests across Europe, with some exceptions. Now let me just quickly switch to carbon. So, well, if I just go back really quick. In all of these sites in Slovenia where we have long-term permanent plots, we can also measure carbon, right? Because carbon's pretty easy to measure in a forest if you measure all the trees, at least the above ground carbon. So these are all the plots that we have in our old growth network. Maybe you recognize some of the names, right? Šumik, Reichenau, Pečka, places like this. And on the y-axis is the total amount of above ground carbon per hectare. So the green is living carbon, and this, I don't know, is that beige, something like that, is dead carbon, all right? And what you see is that on average, there's about 200 to 250 tons per hectare. So that's a lot of carbon being stored in these old growth forests. And I'm not talking about soils, there's a lot in the soil too. And I think, I don't know, Aleš might have to correct me, but I think the latest data in Slovenia is our managed forests have about 80 to 90 tons per hectare, which is still a lot, but it's about 2 to 3 times less than what we store in old growth forests. And this holds true no matter where you go in Europe, right? If you look at any carbon data, right, where we've collected this data all over Europe in old growth forest and formally managed forest reserves, the amount of carbon is pretty high. So often between 200 and 300 tons per hectare. Of course, it's lower in less productive forests in the boreal zone, higher in more productive forests like in Bosnia. But in general, these old growth forests store massive amounts of carbon. What is also very important is to look at where the carbon is stored above ground. So I know this figure is a bit complicated, but let me just explain it. So this is taking all of this data from all these old growth forests across Europe, and then plotting the diameter distribution here. So in most forests, right, in old growth forests, most of the trees are small, and a few of the trees are really large, right? That's a normal demographic structure. But if you convert this diameter structure to carbon, you can see a totally different relationship. It turns out that almost 75% of all the carbon in these systems is maintained in the few trees that are above 50 centimeters in diameter, right? And almost half of it is only in the trees that are 70 centimeters in diameter. So very few of the trees, but the very large trees, have most of the carbon. And this also holds for our old growth forests here in Slovenia, right? Oops. So almost 80% of the carbon is stored in the trees that are above 50 centimeters in diameter. I'm showing you that because if you remember back to the slide I showed you before, we don't have that many really big trees in our managed forests. And Slovenia is probably doing a lot better than many other countries in the EU as far as maintaining big trees in their forests. But if we want to have more carbon in the forest, we'd be better off leaving these big trees in the forest. The reason that is most people think, when trees get big and old, they don't really perform very well anymore, right? They're kind of thought as these stagnant reservoirs of carbon. But that's very far from the case, actually. There's been a lot of studies on this. This is one very classic one where some researchers looked at the amount of basically mass growth related to diameter in hundreds of species all over the world. And what you notice is this kind of exponential relationship here, right? So basically showing that trees continuously increase their mass year after year after year. So if you imagine a really huge tree, right, a sequoia tree or a massive fir tree, and you took an increment core from it, it would have a really tiny growth ring. It might only be growing 1 millimeter or 0.5 millimeter. But when you add up all that carbon across its entire trunk and branches, right, as a certain kind of volumetry, then it turns out that that's a lot of carbon, and it's always more than the year before. And in some cases, the amount of carbon that these very large trees can put on their stem in 1 year is greater than the total amount of carbon that a medium-sized tree would have. All right, so these old growth forests are not just kind of stagnant, stable pools of carbon. They're still increasing the amount of carbon that they're adding, okay? All right, I'm getting to the end now. So if you remember back to the beginning when I said, well, there's two different ways to basically balance the economic and the ecological functions of the forest. It turns out that those two approaches, especially the land sharing approach, does not work that well, okay? So we have to figure out a better approach to do this, all right? I told you in the beginning that so we need to produce a lot more timber. So we have to ask ourselves, if we want to have more forest reserves, if we feel that that's important as society, and we know that we need to produce more timber, how are we going to do that? Right, that's not so easy. And in fact, the two EU strategies that was mentioned before, the forestry strategy and the biodiversity strategy, they don't tell us how to do that, right? The biodiversity strategy says we need to protect 10% of our terrestrial landscape. That should probably equate to about 10% of all forest area. The forestry strategy says we should decrease plantations and increase close to nature management. So that should tell you right away that if we did all those things, we would be producing less timber. But we can't produce less timber. We have to produce more timber. And so if you look at the new studies coming out that try to figure out how to do this, the solution that they always come up with is that we need some kind of a zoning approach like triad. So if we increase strict forest reserves to make up for that lost timber production, we need to keep some plantations on the landscape. Okay, we cannot only use close to nature management or else we probably won't be producing enough timber. So I know that might not be what some of you want to hear, but that's just the way it is. If we choose not to do that and we increase forest reserves and increase close to nature management, which typically produces a bit less than a plantation on average over time, and we have higher demand for wood, that means we will offshore our timber production to other countries, often to countries which have less stringent rules and regulations regarding forestry. And if we offshored it to the tropics, then there would be a net decrease in biodiversity globally. So we need to figure out how to produce our timber domestically, and if we want to also increase our forest reserves, okay? This is my last slide. So the take-home message here is that, I don't think that we have enough forest reserves if society cares about those species that need a lot of dead wood. right? So if we only leave 1 or 2% of the entire continent to those species, you don't need to be a conservation biologist to figure out that that's not enough for them, right? It's plenty for bears, wolves, deer, those generalist species that get a lot of media attention, unfortunately, are doing fine, but not many of the species that actually have a very important functional role. This threat that you often hear of increasing climate-related mortality or disturbance in unmanaged forest, I think is unfounded. We should not be saying, oh, we shouldn't protect more forests because they're going to be killed in disturbance. That's actually a ridiculous argument. We want to capture disturbance in large forest reserves. This is why we need to expand forest reserves and have much larger ones when we can. And I think this is one of the reasons why the EU is interested in increasing forest reserves. It's a cheap way to store a lot of carbon, right? So there's a co-benefit with biodiversity. It's good for biodiversity, but we're also storing a ton of carbon in these protected forest areas. And it's a pretty stable storage of carbon, right? It's there. It gives us time to deal with climate change. When we deal with it, then we can figure out what to do next. And finally, I think according to the latest research, we need to use more zoning, okay, to optimize where we produce timber and where we maintain biodiversity. We can't only rely on integrative management to do that. Okay, thank you.